It's the finale, studying for the final part 4. Let's get started. Okay, let's look at this thing. We got an arc here and an angle here. And when we have that kind of shape, we know that our arc divided by 2 is going to equal the angle. The arc in this case is 200, and the angle we don't know. Well, 200 divided by 2, that's 100 degrees equals our question mark. Okay, for this next one, number 46, it's actually very similar. We just have an arc that's practically touching the angle as well. So it's this arc and this angle here. So again, we're going to have the arc divided by 2 equals the angle. The only problem, we don't know what that arc is. This arc right here, it doesn't give it to us. But it's implied because we know the other half, or the other part of the circle is 200, so that means that this other piece here, this has to be 160. How do I know that? Because 200 plus that arc is going to be equal to 360. It's a full circle. So that arc right there has to be 160. So it means we're going to have 160 divided by 2 equals our question mark angle. Well, 160 divided by 2 is 80. So that's our question mark, 80 degrees. Let's do this last one in a different color. Mix it up a bit. For this last one, we have a little more complex relationship. We actually have two arcs. So we have this arc here and this arc here. Okay, so now what we need to realize is that we need to do something with this arc. So I'm going to say the arcs divided by 2 equals the angle. It's either plus or minus, and if it's outside the circle, then it's going to be plus. If it's inside the circle, it's going to be minus. And how do I know that? Lots of practice, lots of memorization, but the general idea is just do it enough times till you remember. Okay, so we got 170 minus 70. Those are 70s. And that's going to be equal to that angle C that we're looking at. Well, 170 minus 70 is 100 divided by 2 equals C. So 50 equals C. So this right here, this angle is 50 degrees. That was 3 in a row. Lickety split. Let's keep on moving to the end. All right, what's next? We got 49. 48 would come first. So 48, we'll start with that. Then we'll move down to 49. So 48 here. Now we got segments. It says solve for x, and we're looking at segments. And when you have segments, it's going to be a piece times another piece is equal to another piece times another piece. So you're always going to have this relationship. Right? Two things multiplied equals another two things multiplied. Well then, that means in this case I'm going to have 18 over 10, or not 18 over 10, 18 times 10, and then the other two, x and 15. So that's going to be 15 times x. So if I simplify that a little bit, I'm going to have 180 equals 15x. Divide both sides by 15, and 180 divided by 15, that should be, what is that? 30 goes into 186 times, so that's 12. 12 equals x. Done. This next one's a little more complex. Again, we start with that general template, two things multiplied equals another two things multiplied. Okay, so when we have that, this is always going to be the outside times the whole thing equals the outside times the whole thing again. Alright, so the outside for this first one is going to be 4. The whole thing from T to E is 10. On the other side, we have the outside is 5. But the whole thing this time is x minus 7. That gives me 40 equals 5x minus 35. So I'm going to add 35 to both sides. That gives me 75 equals 5x. Which means when I divide by 5, x is equal to 15 would be my answer. Let's keep moving. Last 10 or so to go. Number 50. All right, we got the equation of the circle. The big thing to remember with the equation of the circle is we got x minus h, y minus k, and r. And each of these is squared. It's kind of like a Pythagorean relationship. Okay, now this HK, this H comma K is actually a point. It's the X and the Y of the center. And then R, of course, is the radius. So we need to measure those things and see what we get. So here is our center point. That means that the center would be at 1 and 2. And then the radius goes out to the edge here. R starts at 2 but goes up to 4, so that R is equal to 2. So let's fill in these pieces. We have x minus something squared plus y minus something squared equals r squared. So if we fill those in, the x center is 1 from here, and the y center is 2 from here. The radius is going to be 2 as well. Slightly different color there is orange. So now let's simplify. The x minus 1 squared, can't really simplify that, so we just leave it alone. We're going to just write it as x minus 1 in parentheses squared, plus the other one's y minus 2. That's in parentheses squared as well. Then this last piece is 2 squared here, which would be 4. That would be simplified, so be sure to make a note of that you do have to simplify squares. Let's keep moving. We're on 51 and 52. We're looking at lateral area. Lateral area. Lateral, I like to think of as the wraparound. Sometimes I like to refer to it as kind of like the belt. So let's look at this piece here. We got a 1-inch radius and a 1-inch height. Something that's helpful to remember is that a cylinder can be broken up into 3 shapes, a rectangle and 2 circles. And this rectangle in the middle, it's got a height of 1, but then this dotted line around the outside makes this dotted line across the top here, which is the circumference. And the circumference is equal to 2 times pi times the radius, which in this case is 1. So that's 1. The top here is 2 pi. So the area of this rectangle is 2 pi times 1, or just 2 pi. Now again, it's only asking us for the lateral area, so we don't need the bases. We don't need the top circle or bottom circle. We just need that wraparound piece. So the lateral area, also referred to as capital L, is equal to 2 pi. Let's look at this one now. So we got a 4.8, a 9.3, and a 7. One of those we don't need. I'll tell you which one we don't need. It's the 4.8, because it's a measurement dealing with how to find the area of this base. We would need it if we were finding the total surface area, but we're not. We're just finding these triangles going around the outside. It's helpful to realize what this net would look like if we were to break it down to 2 dimensions. So it starts kind of with a pentagon looking like that. Then each of these pieces is going to become, a pointy triangle. And they're all congruent. I know mine aren't, but they should be congruent. So we have 1, 2, 3, 4, 5 triangles, and if I didn't know that, I could just count the sides here. 1, 2, 3, 4, 5. And the area of a triangle is equal to half the base times the height. So I'm going to take that and then I'm going to multiply it times 5, whatever that would simplify to. Well, the base in this case is 7, and the height is 9.3. So let's simplify that. We'll do half, so 1 divided by 2 times 7 times 9.3. That's 5. Now I need to take that and multiply it by 5. 32.55 times 5. This times 5, let's go back, times the answer times 5. Second answer times 5 equals 162.65, or 75 equals 162.75. Now again, I don't need this part that I just shaded in. I'm just looking for those triangles, so that's all that I need. That is my total area. And actually we don't refer to it as A for this area. We have more specific reference. It's L. The lateral area equals 162.75. Okay, now we're finding total surface area. This is a little more specific. We might need to go to a thinner pen here. So let's start with the first one. It's a pyramid. We break down this pyramid into a net. And this net is a pyramid, so it's got the four triangles plus the base. Now those four triangles, that's not too hard to find. The area of each triangle is going to be half the base times the height, which in this case is going to be, each base is 10, and the height there is 10.3. And we got 4 of those, so we got to multiply that by 4. So it's going to be 4 times 1/2 times 10 times 10.3, which is actually going to simplify to, I think, 206, but let's double check. It would be 4 times, or 4 divided by 2, which is the same as 4 times 1/2, times 10 times 10.3. 206. So that's the lateral area. So that counted 1, 2, 3, 4 triangles, but now we need this square in the middle. But that square is pretty easy. It's 10 by 10. So that base area is equal to 10 by 10, which in this case is just 100. So we're going to have the base plus the lateral area equals 306, because it's 206 plus 100. So that's what we were really looking for. Now these last couple here of surface area are going to be probably the most complex problems in the entire test, but we are ready to tackle them. Okay, let's start with the shape. I'm going to use my special shapes here just to keep it a little clean. So I'm going to start with a pentagon, and then from this pentagon I need triangle, or actually rectangular pieces. There we go. Okay, so we got a rectangular piece, and each of these rectangles has a height of 6 and a length of 9. So we got 6 here and 9 here, and it's 9 as well on the other side. So that means this is going to be 45 for each of these rectangles. Now for this piece in the middle, let's use a slightly more contrasting color, how about blue? We need to split it up into triangles. And all these triangles are congruent. Each of them is going to have a base of 9 and a height right here of 6.2. So that's 6.2. So let's figure out one of those. The area of just one triangle would be half times 9 times 6.2. And then we're going to multiply that by 5 to get the total. So that'd be 1 divided by 2 times 9 times 6.2. And I'm going to go ahead and multiply it by 5 because there's 5 of them. That gives me 139.5. So inside here is 139.5. Outside I have 545s. Now here's a slight catch that we need to be aware of. We have two bases. We got this one going around the top, and we got another one going around the bottom as well. So we got to double that. So 139.5 times 2 gives us 279. So the bases, since there's two of them, is equal to, what was that, 279 I think? Yeah, 279. And then we have the lateral area, which is the part I did in red, and that was 45 times 5, which equals 45 times 5. That's 225. So I'm going to add those two things together. That plus 279 is 504. So these two pieces put together equals, as we just saw here, 504. 504. Now I'm going to skip this last one. It's just a triangle. I'll start with the net for you. But you would find there's your base, and then you'd have 3 triangles going around the outside. And the base here is 10, 10, 10, and then this piece is going to be 8.7. And then for these triangles, they're 11.4. So you got 3 triangles with a height of 11.4, another triangle with a height of 8.7, and the bases are all 10. Find all the areas, add them up together. That gives your answer. All right, the last 5 problems here that we're going to look at are volume. Lots and lots of volume. So the cool thing about volume is you just have to answer 2 questions. Is it pointy? Yes or no. And then what's the area of the base equal to? And then what's the height? I guess it's 3 questions. If you can answer those 3 questions, you can find the volume of anything. Let's start with this. Okay, it's not pointy. So if it's not pointy, the volume is just going to be the area of the base times the height. Now the trick is identifying the base. The base is the face that has just one partner on the other side. So if you look at this, I got one dotted and one solid trapezoid, and together those make the 2 bases. So I need to find the area of that trapezoid. The area of a trapezoid, which is my base, it's going to be the 2 bases added together of the trapezoid. I know we hear the word back and forth. So this 3 and this 6, I'm going to add those together. And then I got to multiply by the height, which is 2.6. We got to divide that by 2, because it's half of that. And we got to multiply that by the height of the prism, which is 4 right here. So, actually, you know what? Let's kind of erase some of this. Keep it simple. We're just going to do b, and then we'll multiply that by the height. So this is going to be 9 times 2.6 divided by 2. So we got 9 times 2.6 divided by 2. That gives us 11.7. So 11.7 is our base. So then the volume is 11.7 times the height. And the height in this case was that blue piece because it's stretching. All 4 of these legs are stretching the 2 bases together. So it's going to be 11.7 times 4, which would be 44 plus 20, 46.8. There we go. Next, let's do this one in red. It's way easier than you would think. So let's ask, is it pointy? Yes, it's very pointy. That means that our volume now is not just the base times the height, but we also got to multiply it by 1/3. So let's first talk about the area of our base. The area of our base here is just a rectangle. It's 4 by 6. So it's going to be 4 times 6. And we got that 1/3. And we got to multiply that by the height, which is also 4. There's another 4 in there. So we got 4 times 6 times 4 divided by 3. Well, let's see what we get then. 4 times 6 times 4 divided by 3 equals 32. So the volume of this is 32 kilometers cubed, of course. And over here, this was 48 kilometers cubed. That was huge. 46.8 cubic kilometers. This is 6 kilometers. My goodness. All right, I'm going to skip 58 because it's just like 57. Rewatch 57 if you need to. Okay, number 59 is similar to each of those, but it's got a slight difference. The slight difference is that it's got a different shaped base. And the base here is a circle with a radius, or is that a diameter? That's a diameter of 6. That means the radius would be 3. That means the area of the base is going to be pi r squared, which in this case is 9 pi. So that's the area of my base. And this is pointy. It comes to a point right here. So that means the volume is 1/3 times the area of the base times the height. The height in this case is h. So it's 1/3 times 9 pi times 8. Well, the 1/3 and the 9 is just going to simplify to 3 pi. That gives us 3 pi times 8, which is 24 pi. I like pi. Number 60. Okay, answer the first question. Pointy or not pointy? Not pointy. So that means it's more like a prism type shape. In this case, it's more specifically called a cylinder. But I would actually like to call it a circular prism. I think that would be interesting. Okay, so then we have, it's not pointy. That means the volume is just equal to the area of the base times the height. In this case, the base, again, is a circle. So if the base is a circle, that means it's going to be pi r squared. And then the height, again, is just height. Well, let's figure what r squared is going to be. That's going to be 4 squared, and then the height is 11. Well, 4 squared is 16, so it's going to be 16 pi times 11. And 16 times 11, let's get lazy and use our calculator. 16 times 11 is 176. So this is 176 pi, and guess what? We are done. Done, dun, 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 done. Good luck, and happy stars.